So let's take a look at our work for today. The polygons in each pair are similar. Oh, interesting. Last week we talked about similarity, right? We talked about size being proportional. So find the scale factor of the smaller figure to the larger figure. So we see some shapes here. One shape is smaller than the other, but something about a scale factor. Now, scale factors, we do see them in life, right? If we go and look at model car kits, if I zoom in, let me see here. I search and I see here, it's a big, it says 1 through 16th. You guys see 1 fraction 16th. Okay, so it's the scale here is 1/16th. However, it also gives me here a scale of 1 colon 24th. I can see it as a numbers there with a colon. You guys see the 1 colon 24th, and you guys see it as a fraction, 1/16th. What does that actually mean? Here, the 1/16th is on the scale fact on the toy card, 1 inch or 1 centimeter or however you're measuring it, but let's say inches. 1 inch in the actual toy is 16 inches in the actual car. So let's say you had an airplane model, or you had in this case, this car model. You're like, I wonder how big is the windshield, or I wonder how big is this headlight or the tire. You wonder how big is a certain part of the card. You measure it, and it says 1 inch on the toy card is 16 inches on the real case. And then same thing here. Let's say you were to have one of these cars, and you're like, oh, I wonder how big are they in life, in actual life. 1 inch in the toy card is 24 inches in the real card. So that's what scale means. So we can see it. We can do the scale to find out how big the items in real life are. So that's what we're gonna move in here on the scale. We're gonna use this that we call the scale factor. Now, couple things here. The word 2 is very, very important. Find the scale factor of the smaller figure to the larger figure. We're gonna choose 2 numbers that are corresponding to our pictures here. I'm gonna choose this 16th. I'm just gonna choose one measurement of one triangle, and I'm gonna choose the corresponding measurement of the other triangle. Now, smaller figured to the larger figure. So it wants, the way I read this, I read that the smaller figure first, right? The instruction says smaller figure to the larger figure. So in my case, I'm gonna go the small numbered first. Couple of ways I can write this. I can write this as 16 over 40. Remember how we saw it as a fraction? Or I can write this as 16 colon 40. No spaces altogether. Now I'm gonna say we're gonna use this case. We're gonna write it in this case. We're not gonna write it as a fraction. We're gonna write it this method. We're gonna write it using the colon. Now, one thing. Remember how fractions can be simplified? If I saw this as a fraction, 16 over 40, remember how you remember how to simplify? Let me divide top and bottom by the same number. In this case, let me divide each by 8. So 16 over 40, shouldn't that simplify to 2 over 5? Well, guess what? 16 colon 40 will simplify to 2 colon 5. That's going to be my scale factor. This is how we're going to write scale factor. We're going to use the colon method. However, make sure you simplify your numbers. I'm gonna simplify both of my numbers by the same thing. 16 and 40, I divide them by the same thing. So my answer is 2 colon 5. Again, all together, no spaces. Okay, let's take a look at number 16. Oh, before moving to here, some of you might be, Mr. Leonzo, could I have gotten the 10 and the 25? So could I have gone 10 colon 25? Yeah. But what if you simplify that? I will divide each by 5. So that gives me 2 colon 5. You notice how you get the same answer? So it doesn't matter which side you choose. as long as you choose the corresponding side on the other figure. Now, this 25 goes with this side. I don't know what the measurement is on the small side, so I'm not gonna be able to use that 25. So let's take a look at number 16. I can use any of the numbers that I want, as long I use the corresponding figure, the corresponding number on the other side. My 20 goes with 24. And remember how here I said smaller figure to the larger number? So I mentioned the smaller figure first. So I'm gonna write this as 20 colon 24. Again, we could write this as a fraction, but in this case, we're not gonna write it as a fraction. We're gonna write it as a colon. So 20 colon 24. And remember how I said that you must simplify your numbers? Let me divide each of these by, I don't know, by 4. We could divide this by 4, right? 20 divided by 4 is 5. Colon 24 divided by 4 is 6. So my answer will be 5 colon 6. Again, don't forget to simplify your fractions, or in this case, simplify your numbers. Now that we know how to use scale factor, we're going to be able to solve for x. We're going to use it to solve for sides. The polygons in each pair are similar. And remember, we're solving for x. Notice how one of my figures is called b, and then one of my figures is called 8. And I only have one measurement for each of my figures. Okay, so scale factor from A to B is 1 to 2. Okay, A to B. So for solving, I will use a fraction. For solving, when I'm solving for x, I'm going to use the fraction. So it says A to B. Notice how I label the letter A first. So the value that comes from A is going to go on the top of my fraction. Sometimes my x will be on the top of my fraction. Sometimes it will be at the bottom. At the bottom, I'm going to have the information that I have from B, which is 3x minus 5. Okay, in order for me to solve for this, I have to let it equal to something. But I see my scale factor is 1 to 2. So I'm going to let this equal to 1 over 2. Now that's easy. Let me cross multiply it. Every time I see a plus or minus, I'm going to multiply the other number, the one that is by itself, times 3x and times 5. So 1 times 3x, and then minus 1 times 5, it's equal to 8 times 2 is 16. So I have 3x minus 5 is equal to 16. Let me separate my sides through the equal sign. To get the x by itself, this minus 5, let me move it to the other side as a plus 5. So that gives me that 3x is equal to 21. To get the x by itself, let me divide both sides by 3. X is equal to 7. You don't have to type in x equals, you just type in 7. Good. Let's take a look at number 18. Scale factor from A to B. So again, the information from A goes on the top. So I'm going to write this as 12 over 2x plus 6. Remember, I have those two informations there. Because it's at A to B, the information of A goes on top. If I had said the scale factor from B to A, then put B on top. But here I said A to B. And this is going to equal to 2 over 3. You see where I got the 2 over 3. Okay, let me cross multiply to solve for x. I'm going to go this way. Because of the plus side, the number that by itself, I'm going to go 2 times 2x and then 2 times 6. This number by itself has to be multiplied to both of these. So 2 times 2x is 4x. Then there's a plus sign. 2 times 6 is 12. And this is equal to 12 times 3. That's 36. Okay, let me look at this as a simple algebra question. This plus 12, right, the number that doesn't have a letter, I'm going to move it to the other side. Don't forget to switch the sign. So this plus 12, let me write it as a minus 12. So that gives me that 4x is equal to 24, right? 36 minus 12 is 24. Let me divide each side by 4. So that's going to give me that x is equal to 6. All right, so the first question was not too bad. That first assignment, not too bad. So that's how we do scale factored.